my students a lot, so I chose it as a topic to explain. Many times they ask me, or they don't understand, when they see something like 3x minus x, they're not sure why this equals to 2x. I tend to get the question, why are we subtracting 1 from 3, but not x from x, right? Why does the subtraction work for the number, but not for the variable, for the x? And this is very important to understand because it's a fundamental pillar of algebra. So if you learn the why of this, everything just becomes much easier. So I'm going to explain what is going on here, and then I'm going to use what we learn, what we hopefully will learn about this to solve an exercise that is pretty common in tests. Okay, that uses algebra to find the answer. So what's going on here? Why is the x not disappearing, right? What's x? X is just a placeholder. You can think of it as that. X could be any number, okay? And the reason why, you could ask yourself, why are we writing x and not the number? Because sometimes we don't know it. And we use this notation to find it, right? That's what I'm gonna show in the second part of my explanation. Okay, so I'm going to talk about what 3x is. What does that mean, right? 3x in math simply means we are adding x to itself 3 times. Okay? Why? Because that's what happens when we add a number to itself 3 times. We're just multiplying it by that number. So in other words, we're just following the times table. If we think of x as any number, for example 2, I would write this as 2 plus 2 plus 2, right? If you think about, again, the times table of 2 in this example, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. We're simply adding 2 to itself a certain number of times. Adding it 3 times means we're multiplying it by 3. 3 times 2 equals 6, or 2 plus 2 plus 2, right? Okay. So this makes it really convenient and fast to operate with a placeholder or variable like x. The number that multiplies it is the number that we're adding it to itself. Now, what happens when we subtract it? Why does the x not disappear? Well, if you just look at what we're doing here, summing it up, we can use that to see subtraction. Why is 4x minus x 3x? Okay, let's break this up. We just said before that 4x is equivalent to adding it 4 times, right? X plus x plus x. All right, what are we doing after multiplying x by 4? We're subtracting 1, x, okay? So I'm gonna focus now on this part of the line. What is x minus x? What is a number subtracted to itself? No matter what number you think of, that's going to be 0. Okay, so we say we cancel those x's out. We can forget about them because they're 0. And we end up with x plus x plus x, 3x. So you cannot, that's why you need to keep your x when you're subtracting in this manner. If you take away x from it, you're no longer talking about the x times table. Okay, because there's a number there that you're multiplying by that you don't know and that you have to keep, okay, to maintain the logic. All right, so now I'm going to use this to hopefully help you understand like I said before, a common exercise that shows up in tests. And that is, how do you convert a recurring decimal, which is a number that repeats to infinity its decimal part, right? So the way we write recurring numbers is with a dot, sometimes an arc, over the number that repeats itself. So 0.1 with a little dot or arch on top just means 0.111111 repeated indefinitely. Not indefinitely, but actually to infinity. Okay? So how do we make this a fraction? How could we express this as a fraction or division? That's what fractions are, a division, right? Let's see. We are going to use x. We're going to call that fraction x. We're going to say, oh yeah, 0.1 recurring is a fraction. I don't know which one it is, so I'm going to call it x. This is why x is so useful, and you'll further see in a bit. Okay, the method goes like this. First off, I'm going to multiply my number, my fraction that we don't know of yet. I'm going to multiply it by 10. Okay, so that's 10x, right? 10 times x, 10x. Remember that x was our fraction and our recurring number. So I'm going to multiply our recurring number by 10 also, just like I did with the x. My recurring number becomes 1.1 recurring. We move our dot one position to the right when we multiply by 10, and that's just what I did here. Okay, now this is very useful because I'm going to get rid of the recurring part of the number. How am I going to do that? I'm going to subtract 1.1 recurring. Sorry, I'm going to subtract 0.1 recurring from 1.1 recurring. Okay? Doing so, I'm going to end up with 1. If you think this is a bit too strange, you could check this subtraction in the box form, and I'm going to do that here for clarity. So I'm subtracting 1.1 recurring, right? So this number to infinity again. Sorry, I'm going to subtract 0.1 recurring from 1.1111 recurring, right? So basically, this is what it looks like in box form. All right. Now check this out. The whole decimal part is going to be always 1 minus 1, right? Which is 0. 0, 0, 0, 0, up to the units. where we're not going to have 1 minus 1 anymore. We're going to have 1 minus 0, which makes 1. And this is what I was talking before, saying that doing this is going to make it much easier, because 1 is 10x. Remember, 10x was 1.1 recurring minus x minus 0.1 recurring. Okay, we learned a moment ago that subtracting x's or factors of x, that is just one number multiplying x, gives us the term multiplying the x subtracted, right? So this would be 10 minus 1, 9x. Okay, and now we're almost done. To get x, we simply need to divide by 9 both sides. And that gets us 1 over 9. Okay. Forgot to rewrite this step here. This was our 10x minus our initial x. All right, if we go back, we have just expressed our number, our problem number, as a fraction. Okay. So hopefully it was useful to you, and see you soon.